Scott Francis here with Westex. I'm the technical sales manager for Westex. As many of you may know, Westex manufactures flame-resistant arc-rated fabrics. We don't make the PPE, we don't make the clothing, we make the fabric that goes into a lot of the clothing that's out there. Good morning, good afternoon, wherever you're from. I'm presenting live from lovely Chicago, Illinois. The weather is absolutely beautiful here. September is a great month. We're excited for this month. Our Bears are going to get underway this weekend, and we're excited about that. The 3-0. Oh, I forgot the preseason doesn't count, right? Okay, well, I thought that I was hoping that would, but they're looking pretty good. We're excited. Actually, I'm going to the game on Sunday against the 49ers, so I'm very excited about that. And I bring up football because I see parallels between football and electrical safety programs. Of course, football is a game of progression. You got to get, better a little bit every week to compete. Just like electrical safety programs, we got to get better. We got to get our program bigger, stronger, faster in football terms, right? And of course, there's challenges along the way. Football, you got tough competition. You have injuries. Well, let's face it, in electrical safety, there's always challenges. You're adding new equipment, maybe taking out equipment, and always you have the challenge of finding new qualified skill electrical personnel. That's a challenge, especially in today's economy. So there's parallels there. So in addition to those parallels, as you look at the agenda here, and I'm going to go quickly so we have some time for questions. Basically, as you look at the agenda, I really have three take-home messages here, if you will. When you're talking about 70E and electrical safety, it's really not a one and done. It's not a checklist to check off that it's done. It continues to evolve. When we look at 70E and arc flash, the arc flash hazard, when, why, and how to revisit the reassessment, that's what we're going to look at. When, of course, it's every 5 years or when changes or additions are made to the electrical system. Why? Well, the proper PPE selection is only as good as the risk assessment. If the risk assessment of the hazard is, off, is incorrect, then the PPE selection is likely going to be incorrect. And of course, injury risk goes way up. And the how, the last question, how, leads to take home point number 2. For electrical safety improvement and to comply with 70E, we really need to address and improve human performance because, of course, as 70E indicates, in the latest standard, actually came out in 2018, we need to take into account human error in the risk assessment procedure. And that makes total sense because when you look at the data, over 90% of the incidents that are happening in the workplace are linked to human error. It's less than 10% are linked to other risk factors. So, or other hazardous conditions, if you will. And then finally, point number 3, if your organization has personnel that consistently works on energized equipment or consistently puts electrical equipment in an electrically safe work condition, of course, which requires arc and shock PPE, until it's proven that it's de-energized. So if you have those types of personnel, strongly consider a flame-resistant arc-rated daily wear clothing program to serve as both a protective measure, because if it's worn, it will protect, but as well as a preventative measure, and more on that later, that of course reduces the electrical arc flash injury and risk as low as reasonably practicable. So I'm going to go through this fast because I know a lot of people here are well versed on arc flash, but just the basics here. Of course, it's a dangerous release of energy, it's electrons and air, if you will. Of course, it will release radiant and thermal energy. They're very loud. Hearing protection is required, of course, in 70E. And of course, when you superheat air, you get a pressure wave. So with the arc flash, you get the blast. Then there's a lot of debris. These arc flash events are truly molten metal events. You've got a lot of molten copper coming out on older equipment, molten aluminum if it's newer equipment. So that molten metal can also be a risk factor. Not only the radiant energy coming off, the thermal energy coming off the arc can ignite regular workwear, but the molten metal can also be a culprit in igniting workwear. So I think everyone's familiar with, big arcs and small arcs are all measured in calories per square centimeter, as we all know. Of course, the key variables that dictate if the incident energy is going to be large or small are the factors on the left. The big ones, of course, are the amperage, the available fault current. Obviously, the higher the available fault current, the higher the arc energy, the incident energy if there's an arc flash. Voltage is not as critical, just need to have enough voltage to sustain an arc. Of course, another critical thing is the cycle time or the clearing time. The shorter the cycle time or the shorter the clearing time reduces the incident energy. And of course, that's why companies invest in overcurrent devices to keep that cycle time short to lower the incident energies, engineering controls, if you will. And of course, when we talk about using the tables in the standard, the second table, the PPE Cat table, has notes on maximums on available fault current and maximums on clearing time, as well as minimum work distances. And that's so the incident energies do not exceed the ARC ratings of the PPE for that PPE category. And of course, on the right-hand side here, I have distance. Distance is your friend, of course. The further you are away, the better. The incident energy goes off dramatically. And then what do I mean by confined space? That's typically a 70E industrial arc is a confined space because it's on a wall. It can't go, the arc can't go back through the wall. There's a floor because there's one. It can bounce off the floor, so it can be an arc in the box. So in a lot of ways, your 70E arcs have more focused energy than an open air utility arc on the line, because the alignment in the open air is in the slice of that arc. So again, some basics here. I think everyone's familiar with calories per square centimeter. The arc rating is measured in calories per square centimeter. Obviously, the goal is to wear arc rated clothing with an arc rating higher than the incident energy. And to give a frame of reference for calories per square centimeter, 1.2 cals of cal per square centimeter causes a second degree burn on exposed skin. So that's basically 1.5 seconds in a lighter, because the heat flux of that lighter is roughly 1.5 cals per square centimeter per second. So you're in there, for about a second. That's going to cause a second degree burn on exposed skin. And of course, non-typical workwear can ignite as low as 4 to 5 cals. Your lightweight shirts, your t-shirts certainly will ignite at 4 to 5 cals. If you're just wearing regular blue jeans, that's going to take a little more energy, 8, 9, 10 cals, because they're thicker. But you get the picture. Let's review NFPA 70E and why we need to look at the reassessment. Why does the data when every 5 years, you have to do that regardless, or when changes occur to the system. And then of course you need to make sure and verify that the labels on your equipment is updated. Now, why? Well, of course, if there's been changes, if the things have changed, the incident energies change, you need to dictate that, or if the available fault current's gone up, or maybe you've changed the setting on a circuit breaker where it's a longer clearing time, that can affect the incident energy. Could also affect if the PPE category is still valid. If you've changed the system a little bit, will it meet those parameters? Of course, if it's higher incident energy, maybe the arc flash boundary is longer than previous, or maybe shorter if you have new equipment. It may reduce your incident energy, especially on some of the newer equipment. And that can affect other personnel, especially in a task-based program where the supervisor is not wearing PPE because they think they're outside the boundary. Well, if that boundary has changed and they don't know it, they may be in the boundary and they may be at risk. Of course, it affects your PPE selection, making sure you have the right PPE with the ARC rating. It may also change your program. Are you in a task-based program because you don't have a lot of exposure, but maybe when you relook at the risk assessment, you have more exposure on more equipment, you may want to go with a daily flame-resistant ARC-rated daily wear program. And of course, for OSHA compliance, the big one is Code of Federal Regulations 1910.132, which is hazard assessment equipment selection, right? If the hazard assessment is off because you've made changes and it's incorrect now and the label's wrong, the PPE is going to be wrong. And if you have an incident, you may have some burn injuries and may have some explaining to do to OSHA. And of course, the electrical safety program, we're always trying to get bigger, stronger, faster, if you will, in football terms, right? So that's the reasons why. Some review here. I know a lot of these folks here are experts on this, but you need to identify the arc flash hazards, and it may change if you've added or taken away certain equipment. So you need to identify those. And then of course, we need to estimate the likelihood of arc flash occurrence and the potential severity of injury, and then determine if additional protective measures are required, including the use of PPE. Now, the protective measures, go all the way from, the top of the hierarchy, elimination, down through engineering controls, administrative controls, and then PPE is the last line of defense. So again, qualified personnel, consider the design of the equipment is key. Make sure you're looking at the overcurrent devices. The best rule of thumb to determine the likelihood of incident occurrence and severity of injury is really best if both a qualified safety professional and a qualified electrical engineer familiar with the electrical systems look at the equipment together to consider the design of the electrical equipment, the overcurrent device coordination, and determine the operating and maintenance condition of the equipment. If doing the incident energy analysis, of course, if you're doing that method, which is the more precise, more accurate method, if you will, the qualified electrical engineer was certainly going to be privy to the likelihood of occurrence on the equipment. Now, if help is needed, or if you're using the PPE Cat category method, i.e. the tables and the standard, you can utilize table 130.5C. And I have the heading here, if you can see the top there, it's basically the first table you consult if you're doing the PPE category method. And you see here it has the task that you're doing, then it has the equipment condition. It's either in any, or it might be normal, or maybe abnormal, and then it's going to have likelihood of occurrence. Now, if it says no, you don't have to take any additional protective measures. But if it says yes, a yes means that an arc flash is likely to occur. It's not that it might occur or could occur, that it's likely to occur. So you need to take a look at additional protective measures, and we'll talk about that in a second. And that's the first, of course, table you look at, and there's two others that we'll look at here in a little bit if you're using the PPE category method. So hierarchy of risk controls, of course, pyramid, appears on the cover of 70E, that triangle, the latest cover, as you may have seen. And basically it says, for risk assessment, the procedure shall require both preventative and protective risk control methods be implemented in accordance with the hierarchy. Elimination, put in a likely safe work condition if possible, but that's not always possible, as you know. To do diagnostic or troubleshooting, it has to be energized. Engineering controls, awareness, administrative controls, and the PPE is at the last line. Now, some of these, of course, are preventative measures, and some are protective, and some of them can really be both. Like, engineering controls, you may not prevent the arc flash, but it may protect by lowering the incident energy. Obviously, elimination is preventative, shutting it down, putting an electric safe work condition. Administrative controls, preventative. PPE, certainly considered protective measure. If it's worn, it will protect. But I'm going to talk a little bit later about it, maybe looking at PPE, especially a daily wear program, as being a preventative risk control method as well. So again, PPE is usually thought of a protective measure. And of course, when you're in the arc flash boundary, you have to have it on. Outside, you don't. And of course, when you're in the boundary, you got to make sure that it has the appropriate arc rating. And of course, you have to use appropriate safety-related work practices while in the boundary. You can't think you're bulletproof and get sloppy in there. You need to make sure that you're following the correct procedures with the PPE on. And of course, I think what we see out there most of the time, if they've taken the time to have the PPE on, they're going to be focused, and they're going to be utilizing the appropriate safety-related work practices. So let's look at the impact of changes to your system, to your electrical system, or additions on the PPE and the arc flash boundary. Now, if you're doing the PPE category method, if you look at the PPE category method, do the electrical changes additions impact the parameter criteria listed for that equipment type in the PPE category table? So you see here, the top one there, panel boards and other equipment rated to 240 volts and below. It has, maximum 25 kA available fault current. Clearing time is 2 cycles. It has a work distance. So if the maximum has been exceeded on the available fault current with your additions to your program, to your equipment, or the clearing time's been changed, or it's gone beyond the maximums because you changed the setting on the circuit breakers, or adding equipment, then you really can't use the tables if they don't meet these parameters, and you're going to have to use the incident energy method. So every 5 years, or when you make changes, doesn't matter what method you're using, you need to review the data on the labels, because if the info on the labels is incorrect, the PPE is going to be incorrect. So now, if you're doing the incident energy method, which is, AKA the arc flash study method, if you will, you can go to Annex, I believe it's Annex D of NFPA 70E, Informational Annex D. And basically, what most companies do, or the latest and greatest, would be utilizing IEEE 1584. And you want to look at the latest edition, which is the 2018. The last one was 2002. So the 2018 is a better version. It's more accurate, more extensive. Now there's more complex calculations, but it gives you more accurate predictions on incident energies and arc flash boundary distances, which we're looking for. So why is it better? Well, there's a lot of reasons, but some of the key ones are the electrode configurations. In the 2018, there's 5 electrode configurations based on, in 2002, there's only 2. So the 5 configurations, and a lot of you maybe are already familiar with this. VOA was a vertical open air, VCB, vertical conductor in a box. VCBB is vertical conductor terminated and insulated barrier in a metal box. HCB is horizontal conductor in a metal box and an HOA is horizontal electrodes in open air. And what they found is that if you have horizontal electrodes as opposed to vertical, the higher incident energies are seen on these horizontal electrodes. So if you have higher incident energies, that could also affect your arc flash boundaries. More energy means that it's going to dissipate at a greater distance to get to 1.2 cals, which is your boundary. They also found the enclosure size. The smaller the enclosure produced higher incident energy. It kind of makes sense. If it's in a smaller packages, if you will, it becomes more explosive, if you will. Higher incident energies possibly increase boundaries. So look at that if you're doing the incident energy. Now, how do you select PPE? Well, if you're looking at PPE, the third table you look at if you're doing the PPE category method would be this table 130.7 C15C PPE. And I just have arc flash categories 1 and 2 shown. Of course, there's 3 and 4. And I think most people are familiar, for 1, the arc rating in the clothing or the PPE has to be 4 cals, a minimum of 4 cals. For category 2, minimum 8, 3, it's 25. Category 4, the minimum PPE arc rating is 40. I think we're all familiar with that. So basically, with the changes, is the PPE category still valid? If it is, then you can use the tables. If it's outside the parameters for available fault current maximums or clearing time, then you got to go to an incident energy method. Then, of course, the incident energy method's easy. Obviously, you just select clothing that has an arc rating higher than the estimated incident energy at that work distance. So all of this is done because what are we trying to do? We're trying to prevent burn injuries, of course, right? So let's do some burn injury basics here. I'll go quickly because I know most people are familiar with that. First degree burn hurts, but it heals. It's not linked to survivability. What we're concerned about is second and third degree burn because that's linked to survivability. Because really you have 3 factors when you're dealing with burns: extent, severity, and location. Severity and location of the burns are more quality of life issues. What's linked to survivability is extent, and that's percent body burn, which is second and third degree on up is what we're measuring. First degree burn hurts, but it heals. It's a banned sunburn. It will heal on its own. It's not linked to survivability. So we're looking at second, third, fourth degree burns. Now, third, fourth degree burns, they're way worse than second degree burns. Second degree burns will heal on their own. Third degree burns, you're looking at, grafting and surgeries and all kinds of stuff. But second degree burns is going to heal on its own. But when you're talking about survivability, how are they linked? Well, when you compromise your skin, right? When you have blisters, which is secondary burns, you've compromised your skin, and that's an infection pathway. Because typically what we see are a lot of times on these incidents where there's an arc flash and the clothing catches on fire and we got, high percent body burn, a lot of times the guy or the person stabilizes for a while, but unfortunately sometimes, 4 or 5 weeks later, they succumb to infection. And, where do they take you? They take you to the hospital where the bugs are, the antibiotic resistant bugs. So you get the picture. The rule of thumb on burn injury real quickly is the 50-50 rule. 50% body burn and up, chances of survival plummet. 50 years of age and up, chances of survival plummet. Well, it stands to reason. 50% more of your body, your skin, your number one defense mechanism against infection, if it's compromised, over 50% body burn, more opportunity for infection. Let's face it, the older you are, the longer it takes you to recover from everything, right? So you're in the hospital longer, more bugs, more opportunity for infection. So these incidents happen. Street clothing can and does worsen the injury. You can't do anything about your age, but you certainly do something about what you wear. And the term I like to use, a lot of people say it's just FR clothing. The term I like to use is FR arc-rated clothing or flame-resistant arc-rated clothing. Because there's 2 roles of flame-resistant arc-rated clothing. Job 1 is number 1, is the FR, the flame resistance. It's got to self-extinguish. It's got to self-extinguish on day 1 and day 1001. The flame resistance can't wash out. It's got to be a quality fabric where it doesn't wash out because that's job 1. You can't wear fuel. The arc flash, as we all know, 1/10 of a second. Well, we want to keep it that way. If you got flammable clothing, you're wearing fuel, you extend the duration of the thermal exposure. It's like having your finger in a lighter for a long period of time. Job 2 is the arc rating. That insulate, that's your insulative piece. That protects you from getting a secondary burn through the fabric. Like, for instance, if you have a fabric that has an 8.7 arc rating, what does that mean? That means that if I'm exposed to 8.7 calories per square centimeter, there's a 50% probability that there'll be enough heat transfer that will go through that fabric to predict the onset of a second-degree burn through the fabric based on the Stoll curve. So job one, self-extinguish. Job two, insulate, prevent the second-degree burn. Why are we trying to prevent the second-degree burn? Because as I showed you in a few slides ago, secondary burn causes blisters. That's an infection pathway. So we want to prevent blistering. Okay, so if I had one picture to show everyone why arc flash clothing and why, utilizing the hierarchy of risk controls, on the pyramid here, it's because this picture here is sequential from left to right. So the preventative measures put in place were not good enough. The picture on the left shows an arc flash occurred. And then the protective measures on the right-hand side weren't taken into place. PPE wasn't worn because we see the arc flash is over, but we still have molten metal in the air. What do we see? The start of garment ignition. PPE was not worn. So this is exactly what we're trying to avoid. Pictures are worth 1,000 words. This looks like a catastrophic clothing fire. The recovery is going to be very, very difficult. So how do we stop that scenario? We need to get better. We need to be cognizant of human error, and we got to put in measures to improve our performance because over 90% of the incidents are linked to human error. So when we look at NFPA 70E in the latest version, of course, the risk assessment procedure in 70E, of course, the risk assessment procedure shall address the potential for human error and its negative consequences on people, processes, the work environment, and equipment. And it has an informational note. The potential for human error varies with factors such as tasks and the work environment. See informative Annex Q. Now, of course, informative Annex Q and the informational notes are not required to comply with 70E, but some really, really good information I suggest you look at. I talked to a lot of people, a lot of safety people, and they're not aware of Annex H. And Annex A, or not Annex H, Annex Q, which is called human performance and electrical safety. And it's actually applicable to all the hazards, not just electrical hazards. But let's talk about human performance really quickly here. It's an aspect of risk management that addresses human performance that has factors that either lead to or prevent errors. Human performance addresses human error as a unique control that is complementary to the hierarchy of the risk controls. It's complementary to the pyramid. No risk is infallible. All of the risk controls are subject to errors in human performance. So human performance impacts all the preventative and protective measures utilized as part of the hierarchy of risk controls. Now, of course, PPE, personal protective equipment, is one of the risk controls that is most susceptible to human error. The best hazard assessment with the most accurate arc flash information on the label does no good if human error, or lack of human performance, if you will, takes place and the PPE is not donned for some reason. Now, there's ways to get PPE buy-in, and we'll discuss that a little bit later. Now, of course, human error also affects the risk assessment method used, and of course, when to revisit the risk assessment. Complacency is a safety killer and can occur in the assessment procedure or the reassessment procedure, if you will. The erroneous thinking can be, hey, our facility's electrical system really hasn't changed much, right? It's a minimal change, so we don't really need to revisit the assessment, right? Wow, really? How long has it been since the facility's assessment has been looked at? Has the electrical utility that supplies your organization, have they notified your company about changes in the utility's actual available fault current to your facility? Has the utility changed the parameters on the final utility over current protection device? Complacency, procrastination, lack of knowledge, lack of experience, all human error precursors that can impact the risk assessment procedure and when to reassess the hazard. So, have the changes, addition, impact the electrical equipment's available fault current and clearing times? Can the PPE category method still be used? If it can't be used, then we need to do the incident energy analysis or the arc flash study. That needs to happen. Certainly, human performance impacts the risk assessment procedure. So make sure qualified safety personnel and qualified electrical engineers that are called on to perform the arc flash hazard assessment are cognizant of these error precursors and free from these error precursors to better perform the risk assessment or the updated reassessment with the latest tools, such as IEEE 1584, the 2018 version. So they can do that at the appropriate called for intervals. So that's key. These air precursors, they're in every organization. There's situations when the demands of the task exceed the capabilities of the workers or the limitations on human nature. These precursors can be unfavorable conditions that increase the probability for error. They're basically grouped into 4 categories: task demands, work environment, individual capabilities, and human nature. So this is all in Annex Q, table Q5. I suggest you look at it if you haven't already. I've just listed a couple air precursors per group, and I've only listed, one human performance tool to counter these air precursors. There's a whole slew of them listed in the actual table. But basically, this is kind of a worksheet, if you will. The human performance tools on the right, you put those in the middle section, optimum tools with, next to the air precursor you're looking to counter. Real quick, one to think about here. Let's say you have a task at the end of the day. It's a routine task at the end of the day. So you have 2 air precursors working here. You got time pressure because the guy wants to go home, or he wants to go to the local, watering hole, right? Or in its routine. So complacency. So you got time pressure, in a hurry, and complacency. Well, why not utilize the human performance tool STAR? Stop, think, act, review. Self-check with verbalization, because you're verbalizing before, during, and after the task. Well, when you verbalize something, that automatically slows you down. So that would counter the time pressure. Of course, when you're verbalizing it, it also slows you down, also makes it, you avoid complacency. So some good stuff in there. Take a look at the tools. I think that's really good to look at. And when we look at PPE culture, why do people fail to don PPE at the appropriate time? Well, I forgot. Well, if you're rushed or you're fatigued or you're stressed, that all causes people to forget. I didn't know. Well, the air precursor would be lack of knowledge, lack of experience. Of course, overconfidence, complacency. That's a really bad air precursor. That only happens to other people. I'm qualified. I know what I'm doing. I don't need the PPE. It's a quick job. And of course, time constraints. That's, in a hurry, time pressure. And then discomfort. It's uncomfortable. It's too hot. It's too heavy. We'll talk about that more in a little bit. But PPE selection, let's look at that. There's 2 types of programs quickly for the body. When we're talking about body protection, there's task-based and there's daily work for your body. Now, of course, some things are always task-based. For the headgear, it's usually task-based. For the voltage-rated gloves, the hands, and the shock protection, that's task-based. But for the body, there's 2 types. Now, how do we determine which one's better for your organization? Well, the best way to do that, of course, would be you do your risk assessment and talk about risk management. And of course, safety people are really good at that. That's why they get paid the big money to do these types of things. So when we talk about the risk, you look at the hazard, the consequences, and likelihood of consequences. Well, the hazard in this case is arc flash. The consequences could be horrific. Of course, if we're wearing fuel in front of an arc flash, it could be catastrophic. We'll talk about the likelihood of consequences here in a second. And of course, the risk management, the goal is to reduce the risk to as low as reasonably practicable, not practical, practicable, if you will. We're always looking at the way to reduce the risk to as low as reasonably practicable, which involves finding ways to reduce the risk. What kind of time, money, treasure we're going to spend to reduce that risk. So now the likelihood of occurrence is kind of critical, and that will help determine what type of PPE program you go in for the body, task-based or daily wear. Number one, the person's got to be qualified, right? If the person's unqualified, the likelihood of consequences goes way up. So if the person's unqualified, guess what? They're not getting any PPE because they're not working for us on that job. So, A, they got to be qualified. Now, let's say they're qualified. But what state is that qualified person in? What human error precursors are they susceptible to? Are they fatigued? Are they rushed all the time because you're having a hard time getting skilled labor? Maybe they're overworked. What state are they in? Or are they showing signs of complacency that they really know what they're doing? Well, that may, dictate we need to go to a daily wear program to counter some of the consequences of these error precursors that they may have based on their state. And then, of course, the history and current status of the equipment. A case for a task-based would be, hey, it's new construction. It's all de-energized work. We're constructing it. It's not energized. Well, that makes sense for task-based because we got to fire it up every now and again to make sure it's working, or at the end of the project, then we can don the appropriate PPE in that scenario, with qualified people that are in the right state of mind. So these kind of things, the likelihood of consequences can really help determine what type of PPE program for your body you want to go with for electrical safety, task-based program or a flame-resistant arc-rated daily wear program. And the reason I bring this up, because the complacency is a big thing, and we see incidents out there in the electrical industry with newbies, and even stuff with more, happening to more experienced guys. And you sometimes see that in adrenaline sports as well. The newbies, well, lack of experience, lack of knowledge. But why the more experienced guys? Why are they getting in trouble? Now, I'm talking about the ones that have had some experience, not the older ones that have a ton of experience. Hey, they know what they're doing, and they follow the rules, and they wear the PPE. That's why they're working at an old age. But we do have issues sometimes with the ones that have some experience. They think they know it all. And usually what happens is complacency. And it usually happens on the routine tasks, the PPE category 1 and 2 type tasks, not the 3 and 4. The 4, that's a 40 cal exposure, right? Hey, time out. I'm going to the car. I'm going to the storeroom to get the PPE. But when we talk about lower energy routine tasks, complacency can set in, and that can lead to the normalization of deviance, which is the gradual process through which unacceptable practices and standards become acceptable. As the deviant behavior is repeated without catastrophic results, it becomes the social norm of the organization. And once you get to this, it's not good. It's tough to reverse. So you want to prevent the normalization of deviance. The way to prevent that is prevent complacency. Complacency is usually a root cause of the incidents out there, especially at 480. It's considered low voltage, but 480 is a leading killer out there. Now, the way to think about this is think of your daily wear, flame-resistant arc-rated clothing. Think of it as a seatbelt. Think about it. The logic is the same. From a protective measure standpoint, the flame-resistant arc-rated clothing and seatbelts are both types of PPE, if you will. You're not planning on being in a car accident, just like you're not planning on being in an arc flash, but you still wear the seatbelt. You still wear your clothing if you're working on energized equipment. It's a protective measure. If it's worn, it will protect against a catastrophic event, which is important because even if you are a defensive driver or an experienced, well-trained worker, incidents can still happen. Take the protective measures, wear your flame-resistant arc-rated clothing daily wear your seatbelt. The seatbelt, now think about this analogy. It really doesn't work for a task-based scenario as a protective measure. Let's say you're taking a quick trip to the store to get some milk and you're coming back. It's a quick trip. So you're not going to put your seatbelt on. What can happen? It's only a few blocks away. Well, some guy that's drunk comes over the center line and hits you. Hey, it's too late to don that seatbelt. Just like if you're doing a routine task on 480, just doing some quick thing. At the end of the day, don't put the PPE on. An arc flash happens. Too late to don the PPE. It's just too late. Now, let's look at the two types of PPE from a preventative measure standpoint. Okay, so if you got your flame-resistant arc-rated clothing on, just like a seatbelt, they're both constant, proximate, tactile triggers to set your appropriate safety mindset so that you can access your safety training. So your clothing, even more than a seatbelt, because you tend to forget about the seatbelt over time, but it's a constant, proximate, tactile, you can feel it. And when you extend your arms out, you can see that I'm wearing flame-resistant arc-rated sleeves. Oh, it's a trigger to access the mindset to, oh, I should probably put voltage-rated gloves over my flame-resistant arc-rated sleeves. Oh, I should put my task-based headgear. So think about it. A daily wear can be a protective measure and a preventative measure because it's there. If it's a task-based thing, a lot of times those aren't worn. Out of sight, the bag of safety sits in the locker, sits in the truck. Out of sight, out of mind, no help being a preventative measure as well as a protective measure. So what can happen if you have a situation where you didn't don the PPE at the appropriate time? You're wearing your natural fibers underneath. It's just a routine task. What can happen?
This is cotton clothing in a category 2 arc. However, this arc is going to do something different. It hits the ground and rolls out a good 10 feet, and the garments are instantly on fire from the shoes right on up. The entire mannequin. This is a very, very fierce fire, obviously. You're going to suffer massive, if not total, body burn.
I think a lot of you have probably seen these videos. They're on our website, Westex.com.
You're going to see the arc once again come out of the box, hit the ground, and roll out at least 10 feet. The mannequin is going to be instantly on fire, pants and shirt, from the ground right on up, clearly illustrating the fallacy of wearing non-flame resistant pants on the assumption that the arc will hit you in the chest.
So a switching coat or a lab coat and just regular pants, not a good idea. Head to toe. 70E requires head to toe, well known.
In frame by frame, coming up shortly, we'll get another very close look at this arc. You can see that after the second cycle or so, It's on the ground and a great distance from the arc gap, completely enveloping the mannequin, putting out a large amount of molten metal, and again, causing the fire.
So obviously cotton's not an upgrade for your electrical personnel. And if they don't put the task-based PPE on, you could have this incident. You could be wearing fuel. You contrast that with flame-resistant arc-rated.
Ultra soft pant and shirt, category 2 arc. And as you can see, there is no fire on the garment after the arc is over. The flame-resistant clothing did its job. In slow motion, you have a very good look here. The arc comes out of the box, wraps around to the left of the mannequin and around his back. Large amount of molten metal is thrown out as well. But once again, when the arc event is over, there is no fire on the garment. Frame by frame will give us another look at the arc. See it come out of the box, up the face and chest of the mannequin, and around to the left as well, and around the back. Arcs do unpredictable things. This one was at least 4 feet out of the arc gap.
Okay, so there's risk with both types of programs. I mean, the flame-resistant arc-rated shirt could be, sitting in the truck, or it could be sitting on the work cart. You got to wear the stuff. However, the level of risk of arc flash burn injury is higher for task-based programs because employees who are working around the energized hazards are expected to recognize that and put on the appropriate PPE. You're relying on your employees doing exactly what they're supposed to do 100% of the time. So whenever you have a human variable, there's, subject to these air precursors such as rushing, fatigue, complacency, it's always going to increase the level of your risk if you have these air precursors. So regarding reducing the risk to as low as reasonably practical, or ALARP, involves weighing the risk against the trouble, time, and money needed to control it. If you look at a daily wear flame-resistant arc-rated clothing program, the daily wear program really makes a great case for reducing the risk to as low as reasonably practicable. But FR arc-rated clothing it's too hot and uncomfortable, and my people are going to hate me, and it's going to cause heat stress, right? Well, let's look at comfort and heat stress. Let's look at that. Because when we look at the PPE culture, some of the top reasons people don't wear it, the last one is, hey, it's uncomfortable, it's too heavy, it's too bulky, it's hot, I'm not wearing it. So let's talk about comfort. If you look at daily wear program, that's usually a single layer program. Now you may have a t-shirt, a natural fiber t-shirt underneath, or even better yet, maybe a flame resistant base layer that has an arc rating usually lower, but it's wicks moisture and it gives you extra protection. But task-based, you're looking at multiple layers, right? Because you have your cotton, your natural fiber, and then over that, you're going to have your arc-rated clothing. So it's going to be more uncomfortable, if you will, more layers. Now, again, on the updated assessment, you may have to do some layering, and I'll show you some info on that here in a second, but or you may not. Maybe the new equipment has lower incident energies. Maybe it won't require layering. But if you think about it, that the clothing out there, the stuff has gotten so much better. I've been in this business since 95. And, back then it was stiff, scratchy, it was uncomfortable. Stuff's gotten a lot better over the years. So take a look at it. And if it's comfortable, it makes sense. Now, here's the stuff on the layering. Let's say you do have to require layering. That has to be determined experimentally. You can't add it. It has to be determined experimentally by the fabric manufacturer, or the garment manufacturers can get it. But it's usually more than additive, because remember, you have that air gap that provides additional protection. So again, you got to determine it. It's usually more than additive, but not always. Sometimes you have a heavy outer layer and a really lightweight inner layer. You can get this double hump, and the arc flash the burn can happen a lot at a lower energy than you might think. So again, it's got to be determined experimentally. So comfort's subjective. Heat stress is not. The wear test is the best way to judge. A wear test will help develop a consensus in your organization on what's comfortable. And it's a great opportunity for employee engagement. So on these wear tests, get your influential floor safety leaders, the guys on the floor that maybe don't have safety in their title, but people look up to. Get them involved in the wear test. Because if they buy into the PPE and they buy into the clothing, guess what? The others are going to follow. So comfort subjective, heat stress is not. Per OSHA, OSHA says no single layer, breathable or woven, knit fabric, whether it's flame resistant or not, causes heat illness. Heat stress is caused by poor hydration, lack of rest breaks, lack of shade, poor health. Actually, if it's single layer and it's breathable, It's going to protect you from the sun's load. Actually, I was down in Birmingham, Alabama earlier this summer, really hot day, looking at the hotel. There was a roof. Guys were working on the roof. Guess what? They're all wearing clothing, long sleeve with hats, single layer. Because guess what? They're protecting themselves against the sun's radiation. So in summary, to wrap up here real quick, hey, you got to make sure it's accurate. The PPE's got to, the incident energy's got to be correct, or the PPE is not going to be correct. Can use the PPE category. Have the changes changed where you have to go to the incident energy method? The boundary, has it changed? It may impact others, especially if you're in a task-based program. A lot of times the person that's watching the person doing the work thinks they're outside the boundary. They're not in PPE. Well, if that boundary is changed because you changed the equipment or the circuit breaker and the cycle time is longer, that may change. Again, PPE selection, got to make sure the arc rating's right. Hey, maybe we need to go to a daily wear program, or maybe all this stuff has really reduced our incident energies, hardly any exposure. Maybe we can go to a task-based. And again, we need to comply with OSHA, CFR 1910, 132, hazard assessment, equipment selection. If the hazard assessment is off, guess what? The equipment selection, the PPE selection is going to be off. And of course, we need to get bigger, stronger, faster in football terms for our electrical safety program, because we don't want this to happen to your organization. This, you don't want to happen. This is at a bank. What could be in a bank? Well, there's HVAC. We got an arc flash. This guy comes out first. He's not burned yet. This guy's burned. He's on fire. The first guy that comes out, he burns his hands patting out his colleague. Now, was the PPE out in the truck and they just had a quick job? Well, this guy was wearing shorts, so I doubt they had any PPE. But a scenario where the arc flash assessment was off and the PPE selection was certainly off. So if you have to have an incident, God forbid there is an incident, because it's not always human error. Maybe you're doing something right, but maybe there was conductive dust on the equipment, or someone left a tool and you had an arc flash. This can happen. This is from a dash cam. They're wearing daily wear clothing. So obviously the clothing worked. It self-extinguished. It did job one. And it insulated properly. There's no break open, so it did job one. It self-extinguished. Job two, it insulated properly. Looks like these guys could go back to work right now, but probably they have to go and do some laundry first after an incident like that, I would imagine, right? So with that said, thank you. I hopefully have a few times for some questions. If not, you can email me, or I'll get back to you later via email, scott.francis@milliken.com.
Great. Thanks very much, Scott. Appreciate it. There are some questions. Okay. Why was category 0 eliminated?
Well, that's a good question. The reason being, I believe, is they're concerned about the molten metal coming off. Because even though the incident energy is low, you've got the molten copper coming out. And if that hits and gets stuck in a crack, in a crease, or it could potentially ignite the workwear. So if you recall, 0 required you could just wear natural fiber clothing if it was a category 0. But I believe it was eliminated, and I can't remember what year it was. It's been quite some time now. But if my memory serves me right, it's because of not the incident energy, but the molten metal coming off the electrical gear.
Thanks. Okay, there were a few questions about fabric care, cleaning. What's the recommended cleaning practice for FR clothing?
Well, follow the labels in the garment. That's the best case scenario. The big no-nos, chlorine bleach, avoid that, because especially if you've got cotton-rich fabrics where they're using a polymer in the core of the cotton fiber as the mechanism to accelerate the char of the cotton, repeated use of chlorine bleach will compromise that polymer. So most of the fabrics that I've seen out there say avoid chlorine bleach. The other one is avoid fabric softeners. Now, fabric softeners, the reason for that is that they contain flammable components. The remedy is easy. Just stop using them. They'll wash out. You don't have to ditch the garment. So those are the two no-nos, chlorine bleach and fabric softener. Now, as far as when to take them out of service, that's always a tough question. You want to go with a fabric that's guaranteed flame resistant for the life of the garment, okay? So you don't have to count washings. NFPA 2112 requires the fabric to be flame resistant through 100 washings based on a pretty stringent wash cycle. But bottom line is go with something that's guaranteed FR. And then when you want to take it out of service is basically by, and again, the key is you got to care for it correctly. It's got to be maintained properly, no chlorine bleach and so forth. But if it's getting threadbare or it's got a lot of fraying, a lot of rips and cuts, that would be time to take it out of service.
Okay, next question is about oil contamination on clothing. Somebody mentioned that oil contamination of FR clothing actually adds fuel to the fabric. Does that lessen the FR value?
Yes, it would. You don't want to have fuels on there. Now, a couple remedies for that. If you're doing a really dirty job and there's oils and greases, you have your flame resistant arc rated clothing on, you can wear disposable flame resistant coveralls over that, and they have a very low arc rating, if I recall. But that case in point, if you're doing a dirty job, you got your arc rated clothing on, don't wear Tyvek over that, because that will burn and melt all over you. But so if you're doing a dirty job to spare your clothing, there are some flame resistant disposables you can wear. Now, if you do get a lot on there, you got to take it out of, get it washed and put something new on. Obviously, you want to get them as clean as possible. Now, if there's some residual oil stains on there, I don't see that as being a huge issue, unless it's a lot of it, but if you can get it out, a dry cleaner can take those out. Likes, dissolve likes would be a way to get those out. You want to get them as clean as possible. Think about it. There's those little tags on the garments, right, that say it's PPE Cat 2 or it's 2112 certified or it's FR. Those little tags on there are not they're not flame resistant. So if you have a residual stain on there, I don't think that's a big deal, because if there is some residual flammables in there, it's going to be minimal. But again, try to clean them as best as you can. If you get totally doused, get it taken out of service or get it clean and put something new on. Because yes, that is fuel. You don't want to add fuel to the fire.
Can we consider the risk assessment requirements similar or identical under the Canadian standard?
Well, Z, what is it?
462.
462. That's right. That's right. It used to be like a carbon copy of 70, but they've made some changes, of course. The last version, they made quite a few changes.
Yeah.
So I'm not exactly as up on it as I'd like to be, but I got to believe there's something in there where you do need to reassess the hazard. It probably, I would suggest, it's probably the same time frame. They probably didn't change that. I know they changed. They added another PPE category, if I recall.
Right.
From here, they got a category 5. They made some changes, but that's probably similar in that, hey, every 5 years you got to check this stuff. Doesn't matter what method you're using. And of course, if you make changes, it only makes sense. They're going to have something on that, because if you make changes or you're changing the settings on your circuit breakers, that's going to affect the cycle time. So yes, I would say it's got to be in there. I would be surprised if it wasn't.
Is there any maintenance standards for the coverall?
Well, again, the key thing on that is you want to keep them get them as clean as possible. Avoid solvents and oils and greases. Get them as clean as you can and repaired correctly. So if you do have holes in them, you don't have to ditch the garment unless it's a massive hole. You can use these iron-on patches of like material, of flame-resistant cotton or whatever the material is. You want to make sure it's the same material that you're wearing, and use sewn-on or iron-on patches, if you will, to repair them. And it should be repaired with Nomex thread. So that would be the key things there. Make sure it's maintain that you don't have rips and stuff like that, and that they're clean. Those would be the big main maintenance thing. And then when to retire them, make sure you got a fabric that's guaranteed FR for the life of the garment. Make sure you're caring for it properly, and you should be good to go. And usually when they retire these things, it's usually due to appearance issues. It's faded and so forth, and frayed.
Okay, next comment from Chris is, I see some of my linemen starching their FR jeans. Do you have any thoughts about that?
That's not a good practice. If I recall, in the label of the jeans, it says avoid fabric softeners and starch.
Okay.
So that would be a no-no. And it's in the label of the garments. If I recall, on the flame-resistant Wrangler jean, I remember seeing it said, avoid chlorine bleach, avoid fabric softeners, and starch. So, hey, they don't need to look that good on the job.
Okay, last question. You probably mentioned this already, but just to confirm, is the incident energy analysis method preferred over PPE category?
Well, the feeling out there, of course, is the incident energy analysis method is more accurate, and it is, right. It's more accurate, it's especially when you're using IEEE 1584, the latest edition, the 2018 edition, you're going to get better data. So yes, it's more accurate, but of course it's going to be more expensive to implement. And let's face it, a lot of companies don't have the resources in-house to do that, or let alone contract out with a qualified electrical safety, electrical engineering type to do the incident energy method. So the tables aren't going away, because let's face it, they're way better than nothing. They're not as good, not as accurate as doing the incident energy, but they're pretty good, and they give you some guidance. If, again, the hard part on that is on the PPE Cat method, it's 3 tables you're looking at, but you got to you have to have some knowledge in there. Hey, is the available fault current correct? Are we exceeding the maximums? Are we exceeding the clearing time maximums on the cycle time? If they're below that, yeah, you can use them. So I hope I answered the question. Incident energy, yes, more accurate, but it's not always going to happen due to economics. And the standard has the categories there for a reason, because they know a lot of companies just don't have the resources. So the tables are a good place to start. And actually, the companies that do assessments, that do the incident energy calculations, they use the tables because they're going in from the first get-go, right? To do the assessment, they need to have some guidance. So hope that answered the question.
It did. Okay, thanks very much. I appreciate the presentation. Thanks.